So the goal of this project is for the robot to pick the object, and the object we're going to define whether it's for a cat or it's for a dog, and it should place it in the right place. So the algorithm that's used is a simple one where the object is picked up, and then the robot will first search on its left, and based on the image, whether it's a cat or a dog, it will then make a decision. So in this case, you can see that it takes a bit of time for the image to update, and so because of this limitations, but once it's updated, here it has detected a cat, but we defined that the object was for a dog, so it shouldn't drop it, rather it should turn on its right, and that's where it should be dropped, just as shown here. So just to show that it's working, we've decided to move the image of the dog on the other side. So the algorithm is working in the same way. First searches on the left, and in this case on the left, it should be able to find the image of the dog. Let's see, it's updating. So here the image is a little bit far, nevertheless, I mean, it's able to detect it still. It's able to kind of like detect the image of the dog. So I'm just gonna rerun it again. I've just placed the image a bit closer. The image was a bit far. So again, it takes a while before this image is updated, but once it's updated, you see that it says dog. So this should just drop the object on the left side. So now what we're gonna do is we're gonna run the same thing, but we're going to define the object as an object for a cat, and you're just going to see the thing working now. So again, same thing, searches first on the left, and then the image will have to update, and this takes a bit of time. So this one, I tried to speed it up by increasing the clocking on the Raspberry Pi by doing something called overclocking. It's working slightly better, but it's still like there's still some delay. So anyway, we can see that the cat is detected, and because the object was defined as the one for a cat, it should drop it on the left.